Okay, today I want to talk about IoT, Internet of Things. IoT was popularized by GE when they created GE software, which spawned out of GE Global Research and then eventually turned into GE Digital. At the time, they were creating all kinds of marketing ads, leveraging their NBC resources to go produce a lot of marketing around the concept of IoT, Internet of Things. The whole idea being that GE had a large industrial base, so they made everything from jet engines, wind turbines, power grids, transformers, all kinds of turbines, stuff that would turn like natural gas into electricity, or oil rigs, or trains that would move large amounts of things around all the time. And due to the success of something of Silicon Valley and Google, Apple, Facebook, and friends, it seemed very obvious that the industrialists were going to have to play into the information age. They had already been working in the information age. They had like large IT departments, and they're probably one of the biggest buyers of computers and iPhones and Androids and all that sort of stuff. But they were basically saying something like, hey, listen, we got these jet engines here, and wouldn't it be nice if it was like an iPhone where it came with analytics built in and all these internet services? So there was this large effort to retrofit all the existing hardware with new sensors, and then all the new hardware going forward would have the sensors built in by default. You also see this with like Tesla, for instance, which is probably a prime example of what IoT means to society and as a whole, where basically the Tesla could, in addition to bringing electric power and a faster car, and then slower, with faster response times than say a gas engine, and handles like a sports car, but it also brought on, basically turned the car into a giant computer, right? Where with the artificial intelligence and I don't know if they have artificial intelligence, but with the self-driving car abilities, you can quickly see why Tesla is such a big. The interesting thing about a Tesla, in addition to the self-driving car ability, is the notion that what if you could tell your car to go to the store for you, and then it goes to the store and someone at the store fills it up with groceries, or maybe you make a phone call ahead of time and order what you want, and they just put it in the car, and the car drives it back to your house, and then you unload it from there. You could also, if it gets reliable enough, then you would start to say, oh, okay, well, while on your way back, can you drop this off at the dry cleaners? Can you pick up the kids? Could you get a coffee? And a whole bunch of interesting things start to open up with automation, where you're basically saying, okay, well, the car is like a giant supercomputer slash drone, and its ability to move not industrial, but its ability to move large amounts of stuff without someone having to drive it. One of the better examples I usually give when I'm talking about this is that Uber, right? Uber for everything, right? So Uber's a huge success. But what if you are an Uber driver, and then there's all these Teslas popping up and these self-driving cars? A lot of Uber people would say, oh, wait, then what do you need me for? And I always have to remind them, is like, the most valuable thing that you brought to the equation wasn't your time and to go driving, it was the car. I mean, you're bringing like a $20,000 or $30,000 asset to the table. So what if that car was able to drive itself? What if you just lease the car out to Uber while you go get a coffee or something, and it goes and does X amount of fares for you? And then at that point, you being the Uber driver is no longer about trading time for money with your car. It's about trading your car for money, right? Or the time spent with your car for money. And so in this way, you're probably going to step back and go like, oh, well, how many Teslas can I buy? Can I buy 10? Can I buy 5? Like how? So it's really just a financing game. And then you want to use the proceeds from the Ubers and Lyfts and whatever to subsidize or to finance the whole thing. So then in that case, you're no longer an employee or a self-employed person. You're now running a small fleet of cars, right? So in the GE context, they had a similar problem where they have like a fleet of jet engines or a fleet or a huge number of trains and a huge number of wind turbines, like a wind farm or a power grid. And all these things needed to be managed and optimized. So as you stick on more of these sensors, then they're able to talk to the internet and produce all this data that needs to eventually get crunched down somewhere so that you could do analytics on it and then apply some machine learning or potentially eventually even AI, artificial intelligence, to optimize the usage of those assets by looking at the analytics. Then you're like, oh snap, where are we going to put all this data? Like a jet engine by itself has, like, I forget how many sensors, but it's an insane amount. It produces a tremendous amount of data. And then you're also trying to correlate that data with stuff like weather, right? Or fuel or maintenance or things of that nature. So, and then you're also trying not to void your insurance program or warranty for policy for your jet engine. So it was a twofer, right? Where one, the person who owns the engine is trying to, get 20 or 30 years of use out of this multi-million-dollar engine. But then GE character is also saying like, oh, well, hey, if we had enough accurate data of the performance of this engine, we can give this to our quants who can then, right size the insurance policy so that we're not shelling out multiple millions of dollars for a damaged engine or replacing the engine for free because we didn't get our insurance or our quantitative analysis correct. So obviously they want more data, not less. And then they want to be able to apply things like machine learning and AI on top of it so that you can maneuver like a fleet of jets around, or you can operate a wind farm more optimally and get like 10% more energy out of the wind, not less, right? And so if you're able to get more for less, then obviously you could also increase the life of this, or the life of the asset, so that it won't have to be replaced so readily. Also, if you could figure out, hey, there's this pump or this part that needs to be replaced, and it's a $10 part, but it'll save you, on a multi-million-dollar, jet engine or turbine of some sort. Wow, shouldn't we just, get that fixed right away? So obviously you want alerts and you want the engine to be able to tell you what it needs based off of the manual and the specs and stuff like that. And all this data has to go somewhere. So then they started putting it up into a cloud. So they didn't have a cloud, and so they went and said, well, we don't mind buying hardware. Let's buy a whole bunch of servers. Let's put together a data center. Let's build our own cloud, and then we can store all the data there. We could process all the data there, and then send the optimized answers or smaller data packets back to the asset so that the asset could, if it had switches or controls on it, then the cloud can control the asset, or cloud can send warnings to the pilots or the maintenance personnel to either do the maintenance or to optimize performance somehow. So there was a lot of really interesting things there. But now you're starting to see IoT in everything. So like, for instance, over the weekend I got a smoker, and it came with a Wi-Fi. So I was like, oh my God, you put Wi-Fi on a barbecue smoker? And what was cool about it was a pellet one. So it would use the pellet chips to keep the fire going, but it would only add enough chips to meet the temperature that you were targeting, and then you could also have a meat thermometer in the meat itself. So then you could see what the grill temperature and the meat temperature was, and set it on from your phone, and then kind of like walk off and go do something else while the grill goes and cooks this proper. And I'm sure in the not too distant future, it would be ideal if we're able to actually, remotely tell the grill to start up and have another droid go put food into it, kind of like a Zumba or something. I even saw like a GE, they had stuff for like coffee makers and the refrigerator. So when you put the foods into the fridge, there could be a bar scanner that would pick up the SKUs off of the packaging of the food, and then, or use computer vision to recognize like an apple or an orange or a carton of milk or something like that, and then be able to know what's in the fridge, and then maybe even hook that up to, like, say, an Amazon or a Whole Foods or a Costco or some place like that where you can order stuff. And then as you run out, the fridge can prompt you and ask you, hey, do you want me to just order some more food, and then it'll either be delivered to the house or maybe it'll be put into your shopping basket so that when you go to the store next, you could just pick it up. And therefore you're kind of automating away like the shopping list, you're automating away like all this stuff. So then there was a lot of projects around smart house, smart lab, smart office, smart studio, smart garage, smart cars, smart planes, smart power grids. And the whole idea there was like taking everything that we're learning about how to automate all this stuff, and there's many ways to do it. Now, can we are we able to hook it in with, say, your Nest camera? So now you have a doorbell Nest thingy. So now you have security kind of automated with these Nest everythings. You have indoor, outdoor, infrared, motion detector, time lapses of the previous day from the motion captures. So there's a lot of really interesting things there. And then if you tie that in with your Apple TV for your media, then what if you could just, I think on the Apple TVs or some of the other Chromecast, they have apps for Nest, and then you could see your security cameras from your TV or in addition to your phones or your pads or your computer or your whatever. And so then in the not too distant, and then you couple that with the personal assistants. So then now you can actually talk to your computer from any one of these devices, and it's probably already listening, right? So like an Xbox would have Katana, your Apple TV would have Siri. If you have those Amazon Dots, you have Alexa every which where. A lot of these devices could actually have Alexa on your Apple devices in addition to Siri. You could have Katana, Siri, and Alexa all at the same time on your iPhone, plus the Google Assistant. And so now you're like, oh, wow, this is turning into Iron Man, where Iron Man is talking to Jarvis all the time. And as he's walking around and doing stuff, Jarvis is helping him throughout his day. There was another project called Current. I think GE ultimately spun that out into another company, but it started out of the lighting division where they had all these light bulbs, and they were saying like, so now that we have these LED or LCD light bulbs, the ones that last for like 20 plus years, like what could we do with all these lights? Because they had all these contracts with cities and counties and federal governments or different governments around the world where they would say, hey, how many engineers does it take to change a light bulb? Well, if you're talking about 100,000 light bulbs or 10,000 or 5,000 for like say a university or multiple schools or city buildings or police departments or street lamps, parking garages, that's a lot of light bulbs. So it's actually kind of a interesting problem, and there's a lot of electrical issues that go with that. So GE would typically say, hey, in addition to selling you the light bulb, we'll sell you a contract of service to go handle the installation and maintenance of all the said light bulbs and all the wiring and electrical stuff that goes with it. And so since we already have that, what if we put video cameras and Wi-Fi and two-way audio in the light bulb itself? That way, anywhere there's light, there's already electricity there, but now you can have a security camera built into the light bulb. So you wouldn't even have to go buy a Nest camera and install it separately. It's just like, oh, well, what if when you install your lights, the cameras and all that come with it, and creates a mesh network with the Wi-Fi so that you can move the audio and the video across large distances, and then maybe throw that into the cloud, and then the cloud, or stream it into the cloud, and the cloud could use computer vision to figure out, like who, like facial recognition, for instance. I think China already has a bunch of this. There's a couple pilot programs in New York and San Diego and different places in the EU. But basically, as you go into an airport, you check in with your driver's license or your passport, then the computer starts tracking you as you move through the airport based off of your face. The other thing is that as it gets better at doing the facial recognition and tracking large numbers of people walking through the building through the lighting system, is that you could also, when you check in, it'll probably just go look you up on your on your airlines to see if you have any bonus miles. It might do a quick check-in on Facebook and Twitter or LinkedIn or something so that it can get more background information about you or your check-in status. Or maybe go do a quick query against the FBI and see if you're on some sort of blacklist or whitelist or no-fly list, or there's a million things that they could do real quick, fast, and in a hurry just when you check in just one time, right? And they could see, oh, you're I notice in my phone, it knows when I'm at the airport, and it knows, oh, you're at the SFO, or you're at the Austin airport, or you're in Colorado, or you're in Seattle or something. And it'll actually know which one you're at. And then if you used your email for your registration in say Alaska Airlines or Virgin or whoever sent you an email via your Gmail, then Google's already searching your email, so it puts it into your calendar, and then it already knows that you're at the airport and that you're going from SFO to Denver or Denver to Austin or Austin to Seattle or something like that, right? And it could even tell when your car is parked, and it's like, oh yeah, you parked your car at the airport, it's over there still, because you connect to it via the Apple Care or the Apple Car, Apple Audio thing. I think Dodge had the Connect, whatever it's called. But anyways, now your phone and Google and all these things know that, oh, I'm connected to a car. The car has IoT capabilities. It's talking to, Dodge or Chrysler or whatever, and trying to do the same sort of alerts and stuff that I mentioned earlier, except now some of that information can be shared with Facebook or Google or any one of the big ones like Microsoft, Amazon. And so then, which these companies kind of already do. They already have ad exchanges. So every time you visit a website and see that you 2 days ago Googled for guns, for instance, then you're going to see a whole bunch of ads about that type of gun with that type of manufacturer follow you around because you've been pixeled, meaning that they set a cookie on your computer, and then that's your universally unique ID. And then every time you go to a website that Google that's integrated with Google AdSense, then AdSense will look at your cookie, look you up real quick, and then go oh yeah, this guy was looking for like a handgun or a rifle or whatever, or maybe he's more of a sportsman. So they start building profiles for you, in addition to managing your contacts, your email, your Gmail, your calendars, your instant messengers. They're also starting to manage or build a profile of what you would be interested in order to sell you things, but also feed it to the personal assistant who could help remind you to do stuff, which gets very Big Brother-ish, right? It starts to sound like Skynet. And then you're going well, where's the Terminators? And you're well, technically, that everything that Google was doing with Boston Dynamics, for instance, I think they bought them for some time and then eventually did some development on it and then eventually sold it off. I'm not sure why they sold it off, but those are military-grade Terminators, or more specifically, droids that who knows what they're going to do. Initially, it seems like that they're doing benign things like office work or warehouse work, moving large, heavy items. But then they also got these dog things that run around like the cheetah that can go 60 miles an hour, 20 to 40 miles an hour. Or then they have, I know the Navy spent large sums of money in the form of grants and gift to universities to have the grad students go build out autonomous flying drones. So stuff like not just a flying drone, but also a swarm of flying drones that have a mesh network that could talk to each other and come in and out of the network seamlessly, and then employ things like computer vision, employ things, or go pick up one item, move it from point A over to point B. So even Amazon started picking this sort of stuff up, where they were going so you mean we could have drones deliver stuff in addition to drones help sort all the stuff in the warehouse, and that will help automate the whole purchasing and delivery process of all those wonderful things on Amazon. And Costco's kind of going yeah, right, we need to do that too. But they're buying some of the same drones from the same manufacturers. So whatever Amazon specifically is doing is not terribly unique, terribly different from what, say, FedEx, UPS, Post Office, Costco, Walmart Labs created a whole thing for this, what any of those guys are doing. they're actually probably using the same sort of technology. What makes Amazon unique, though, is that they're not trying to. They have the e-com thing, but they're also pioneering the whole AWS, Amazon Web Services. So a lot of the startups are putting their code on AWS, on Amazon as their cloud. GE even started doing that, where they're like, well, these data centers, this turns out to be really hard to do the data center and to do it fast, and while you're competing with Amazon and Microsoft Azure, and then Google's like, I need to get into the cloud thing too. So it's really hard to compete with them if they're already in the market. They've already put 10, 15 years of effort into it. So all you're really doing is playing catch up with those guys. So what if you, in addition to doing your own data center, you also leverage their clouds? So then you would take your operating system like Cloud Foundry, and then you would put that on your data center, right? So this is how you would be able to spin up databases and spin up Linux virtual machines quickly and easily. Kubernetes is another flavor of that. And then you're making web development kind of much easier from an ops perspective on your developers, because they're able to just push to the cloud, and it kind of virtualizes the whole ops aspect of running a data center. But now you can pick your cloud. You're like, oh, we're on Amazon or Microsoft, or maybe IBM Bluemix, or GE Predix, which is short for predictive analytics. And so now you're kind of going like, okay. And the only common thing between all four of these clouds is maybe Cloud Foundry or Kubernetes. And then if you're a Microsoft shop, then yeah, okay, you got Azure everything. But even they're kind of conforming and saying like, well, we can't do Windows everything. It seems like we're not moving fast enough. And Amazon kind of proved the point that that's not necessarily the only way to go. So you could still use all your .NET and all your ASP and your Microsoft everything with Azure, but you could also leverage AWS. You could also leverage these private clouds or these other industrial clouds, right? And all of them are racing to do similar sorts of stuff, where they want to be the number one host of your data, and then they want to do machine learning on top of your data, and then they want to put AI on your data so that they can learn about your assets, your business, your city, your country, your state, your house, your family, and kind of do Big Brother at scale, which the scary part is that's kind of already happened. Apparently this has been happening for a long time with even stuff like AT&T and Verizon. But anyways, when you mix the technology and the information technology of today with the infrastructure and all the technology and hardware that already exists, it becomes very obvious that this is all turning into a big game of StarCraft, meaning that we're building out our economy, and then as we built out our economy, we're building new technologies and then building up our armies in order to wage war. That doesn't seem too different than reality, where you're basically saying, okay, well, the Pentagon, the Navy, the Army, the Air Force, all those guys want Terminators, they want cloud ability. Even the CIA was saying like, hey, let's create this thing called IQT, InQtel, and that's basically the CIA's venture capital arm, which is designed to go invest in technologies that help the CIA actually do its job of spying. And so they did a deal not too long ago. They did a whole bunch of deals. If you go look at their site, it'll show you a whole bunch of startups that are invested in or funded by the CIA. But one of the more interesting ones was like, say, Hadoop, right? Where Yahoo made Hadoop, and then it was costing them a lot of money. And so at some point they got into talks with the InQtel guys, and they said, hey, why don't we create a new company called Cloudera? Cloud, because we're talking about data and the clouds and stuff. So we'll create this company called Cloudera. You provide the technology, we provide the funding. Then this company will go off and continue the development of Hadoop. You get to use Hadoop, and you can still commit to it, but you're taking the responsibility of owning Hadoop and continue investing in developing Hadoop off your plate. And you're just going to use Hadoop to monetize Yahoo.com. And so Yahoo's like, oh, that sounds pretty cool. And then from the IQT point of view, they're like, and then we'll give all the cool kids drinking the Kool-Aid the cool tech. i.e. Hadoop. And so now you get a Mark Zuckerberg and friends, or the Jack Dorsey and Bizstone from Twitter went and forked, or I don't know if they forked Hadoop, but all these different tech companies needed to be able to do data at scale. Even the CIA or the NSA tried to do data at scale and failed, right? I heard the number was something like they spent like $1 trillion trying to do that. And they didn't do it, but Yahoo was able to do it as open source software, and therefore they were able to do it for free. But now they're giving away this really high-tech database that could do, this is how you look for a needle in a haystack. It's a really high-tech thing, and just give it away to all the kids, all the startups. And so then the venture capitalists can go invest in said startup, and then they would go create things like Twitter and Facebook and Yammer and all these different data-heavy kind of services. But then the second that those companies became successful, because they didn't know which ones would be successful, they were playing the odds just like the venture capitalists were. But when they did become successful, now their tech plugs into the NSA's tech, meaning that, hey, we know how Hadoop works. We have this company called Cloudera. We know everything about it. We even put in the back. So now that you have all this really interesting data, and we have reason to believe that some of that data might have information about different terrorists or criminals or people that are on our no-fly list, I'm just going to take that data now and maybe I'll give you a special tax break, or I'll help you with the whole don't pay taxes thing, just like Armageddon style, where sorry, that was a joke. Where in Armageddon there was a scene with Bruce Willis, and they were being coaxed into taking their patent, making a drill bit, and then flying a spaceship over to an incoming asteroid, then using that drill bit to install a nuclear bomb into the center of it and blow it up. And sounds super dangerous to go try and mount go catch a comet and put a nuke onto it. And so they're like, well, okay, if we live, then we don't want to pay any taxes. And it's interesting because a lot of those tech companies, you're like, well, the government knows who they are. They're making billions and billions of dollars, and they're providing a lot of the tech that the NSA and the government are, in fact, using to conduct the hunt for WMDs, while they're also doing the war on terror, plus the war on drug, plus the actual wars like Iraq, Afghanistan, Iran, which is a proxy fight still, and in addition to the proxy fight with North Korea, and their continued arm wrestling match with Russia and China and friends. And so it's not like the government doesn't know that these tech companies or these countries exist. And in fact, but why do these tech companies never have to pay any taxes? Is because I guess the government doesn't want them to, or maybe there is some back deal room that says, hey, in exchange for this data, meaning ongoing, just keep giving me more data about all the people that I need to know information about, then maybe we don't charge you so many taxes because you're now providing a service that we actually need. So now you're starting to see drones show up everywhere, right? And you're hearing a lot more from Amazon. You're hearing a lot more from Google, Alphabet, and Facebook, and you're starting to see that half these guys are being dragged into Congress to talk about, how the data affected the election. But you're also seeing them talk about monopoly practices. You're also seeing that drones are showing up in real life, and you kind of scratch your head going like, what is going on, right? I even saw some videos of say like a FedEx or a UPS truck driving down down a street, and then from the roof of the truck was a swarm of drones flying out with packages to go deliver them at all the different houses. So instead of a UPS driver, going and handing off boxes one by one, or a postman, it might be like 20 drones on this truck just swarming out there. And then those drones might actually have cameras and sensors on them. And so then there's nothing to stop those drones from doing like more surveillance and more 3D imaging and more computer vision and just like like they don't even need to jump over your gate to get into your backyard. It could just fly over your house. There's already satellites that look down and create satellite imagery. I remember when I was at Google, there was this thing where there was every now and again you'd see dudes from next door at Muffet Field, they were Air Force or maybe even NASA, and they would be walking around in military fatigues at Google. And then there was some issues around Google Maps, I think, was buying a lot of their satellite imagery from NASA, from those satellite, and then a lot of times those satellites were over locations where nuclear silos were at, or maybe where military installations were at, or different military assets that they didn't necessarily want the rest of the world to be able to see just when they're browsing or browsing Google Maps. So then they would have like an army of Photoshop guys go over there and Photoshop all that stuff out so that they can hide some of the stuff. But ironically, there's I do go to Google Maps and Google Earth, you can see quite a bit of this stuff. You just have to know what you're looking for. And there's tons of really crazy information. Microsoft started flying planes over different areas to get the imagery, to get a higher quality one than they were getting from NASA. But now with these drones, like, there's nothing stopping them from getting every square inch of everything. Where you have cars that are drone, even those Teslas are technically a drone now, except they're consumer grade. But even the Tesla has problems when they lose internet signal or cell phone signal and lose contact with the satellite or the GPS. So you're kind of going like, okay, so you need internet everywhere in order to keep the IoT, the Internet of Things, going. And then also you can't, a lot of these products don't really do much without the cloud. So if you take your iPhone, for instance, while it's a powerful thing and it's good for taking videos and photos and it does a lot of stuff on the device itself, it's still, for Siri, for instance, requires to stream the video up to the cloud where it has much more horsepower to do the computation. So every time you're talking to Siri or Alexa or Cortana or Google Personal Assistant, what you're really doing is you're streaming that voice or that audio to their respective clouds, where they convert the audio to text, and then they do either a Google search or they go run it through some machine learning stuff or some AI stuff before it responds back to you. So they're literally able to do mass surveillance with these devices by default. But the way they work is that it has to go up to the cloud. But when you lose internet signal or you're not near your Wi-Fi, you're going to have a lot of problems. So they're like, oh, well, we need edge computing, meaning that we decouple from the cloud and then like have the onboard computer be able to do most of the work. And a lot of people don't have that kind of hardware with them. Maybe their laptop has some ability to do that. We're even noticing, like, say, the Bitcoin mining guys, right? They would get the GPUs because the CPU can do so much processing, but to really find those Bitcoins and to do it quickly, you need a faster GPU. So they were buying out those NVIDIA graphic cards that you would have normally had for gaming, and then was running that to mine for Bitcoins. And in doing so, then they started seeing like that you're using huge amounts of electricity. Because you're running them 24/7. You're not playing a 20-minute game and then letting it rest. You're like, no, I want money. I want money while I sleep. So they might fill up a house with like 100 or 1,000 graphics cards and little motherboards and very minimal computers that only mine. I even saw some dudes that were doing because of the cooling, the heating and cooling thing, just like a data center, those rooms get really hot really quick. So they were using liquid cooled baths. So these things were actually designed to be put into a tub of water, and then they would use a pump to move the water in and out so that it would cool the machines faster. Like Microsoft was saying, hey, what if we had an underwater, data center? Wouldn't that help us with the heating and cooling thing for the data center? So then they started getting like submergible, like submarine style looking boats with data centers and computers to put them in the water and then literally use the ocean to cool it. But to get the Wi-Fi everywhere, you're kind of because the edge device probably doesn't have enough computation ability unless it's something big. Like you could probably have a pretty decent sized computer with lots of computation on a giant wind turbine or on a train engine or on a jet or even in the engine itself, right? In the turbine itself. So, or how about your Tesla? Tesla. Your Tesla looks like a supercomputer anyways. So then all of a sudden, every house could have a movable supercomputer that's battery powered, i.e. your Tesla or your car, right? And then you put the solar panels up on the roof, so you get free electricity. Then you use a power wall or a battery in your garage, which can keep your whole house powered for a couple of days, and also charge your car for free. But then what if your car was like a small data center? So then it would have tons of computation power. You wouldn't even have to go to a cloud to get your personal assistant working, because if you want your personal assistant working to work with your car properly, you need that computation power there. And it has giant batteries, so if it already has the batteries and most of the sensors and the computer, it would make sense that you could get your car to do many different. But still, at times you're going to want to send some of this information back up to the cloud, or ask really tough questions to the cloud where it already has a lot of information, and then send back the answer, which could be a much smaller amount of information than the raw data that you would need to process to do the big computation. So you still need internet access. So then I've been seeing blimps being flown every which where they would put routers on the blimp, and then in this way, if you had a series of blimps, strung out over a long distance, you could actually create a mesh network with that, meaning that blimp A will relay for blimp B, and blimp B will relay to C, D, and all the way around. And so now you can have internet, or at least Wi-Fi, everywhere with just floating blimps everywhere. In addition to the satellites, and in addition to the cell phone signals and the radio towers. You want to be a little careful with the going to G5 because of how much radiation or electricity that's pumping out. And if people are filling it up as fast as they're increasing the capacity, you would imagine at some point, you're walking into like a microwave or an oven of some sort. And so I don't know about you, but I would like to see some studies done to see what the long-term effects of having that much Wi-Fi all around us all the time. But nonetheless, with the blimps, then you could just roll in Wi-Fi whenever you want. So you can roll out to, say, Iraq or Afghanistan, someplace really hard to get to, and you could just float blimps over to Afghanistan and start spreading out free internet for everyone. Then those you could float a data center either in a submerged submarine or a barge. I think Google had the data barge, so they put a data warehouse on top of just a boat. And then from there, they were going like, oh, okay, from here, we could do a lot of the computation on the boat, which we could float anywhere in the world. And we could also use the ocean to help cool it. So it actually has some benefits there. But then we could use the blimp Wi-Fi router to relay the information. And then you could put the drones and terminators on the ground. And then they would be able to talk to the boat via the Wi-Fi and the internet. So on the drone itself, it might have some computing power, but it would still be able to leverage the cloud and the internet and all the computation power from there anywhere in the world. Apparently, we're not just talking about Earth. You could also deploy this to the moon or to Mars, and technically we already have in many ways. We already have Mars rovers in Mars, and they're supported by a series of satellites that are orbiting Mars now. Not too long ago, Elon Musk through SpaceX, launched a rocket into space and deployed an actual Tesla, and then put it into orbit to go orbit around Mars. And so they're just floating that over there too. So you're like, well, okay, what else can we float over there? And so I even seen renderings from NASA where they're like, oh yeah, we could have blimps in Mars or Venus or wherever, and those could do everything from be like a spaceship or atmosphere spaceship or whatever, and those things are controlling those Mars rovers, or pretty soon you're going to have every kind of drone or robot or swarm you could think of, and you would imagine we would start colonizing Mars and Venus in the not too distant future. In fact, Elon was saying, hey, he wants to send the big rocket, the BFH, I think, the big fucking rocket. I don't know what he called it, but it was the big one. It's basically autonomous, the self-flying rocket. and he wants to be able to fill it up with people, and then or first do 2 missions where he sends like 4 or 6 of these things with stuff in it to Mars, and then in 2022 or 2024, somewhere in there, send people after all the stuff has already gotten there. So then and that would be like a one-way, possibly a two-way trip, but a one-way trip to start colonizing Mars, literally. And not too long ago, Trump announced that we're going back to space, i.e. Space Force. Technically, we never left. I mean, we've had the satellites up in the space doing the GPS for us the whole time. We've had the International Space Station up there the whole time. We've had the rovers on Mars this whole time. So it's not like we're going back to space. I think, if anything, it just means that we're going to start exploring space at a much more rapid rate with IoT, and it's very interesting because now you're seeing like, oh wow, everything we talked about in the 80s, drones and flying cars and stuff that looks like magic essentially, or the Jetsons, something like that, is actually starting to come to fruition. It just took longer than 10 years. It took So if this was in the 80s and it's 2018 now, so yeah, like it took 28, 38 years or 30 something years to actually to deliver on it. But here we are, and it's interesting because now you're starting to see IoT is becoming people use IoT for bad things. So in addition to Skynet, right, where you're able to spy on everyone really fast and easily. Well, what if a bad actor gets a hold? Then you're going to start seeing people extort and blackmail each other quite a bit with, over their emails or their tweets or their Facebooks or their Pornhubs or or their whatever, right? We're also seeing it do some good as well. I know in Iran, they had the Stuxnet. So basically that was a computer virus that somebody, they won't say who, but somebody, NSA, somebody, CIA, one of those guys, wrote this computer virus that was put onto a thumb drive, and then they sprinkled it around where they thought the where the centrifuge was at in Iran, like 100,000 thumb drives. And then one of the engineers picked it up, plugged it into their computer, and then it did a seek and destroy routine where it would jump onto the router, look at all the other computers connected to that router, duplicate itself on all the computers, and keep duplicating itself and spreading out throughout the facility until it found the centrifuge. And then once it found the centrifuge, it already knew which centrifuge it was looking for, and the turbines and the firmware and stuff, and caused it to over rev. So if a centrifuge just spins around the yellow cake uranium around it in a circle to enrich it, then if you over rev the engine, just like your car engine, you could redline it and it could overheat and melt and break and also destroy the yellow cake. So you're like, oh, okay, so we can destroy your ability to enrich uranium while destroying said uranium. Oh, that sounds great. Let's do some more of that. Stuxnet all the way, right? And, I think the world saw that and go, well, that's really interesting because that's a good idea. What if we write more software viruses? And what if we deploy them to your power grid or to your cars or to your airplanes or to your stuff, right? So then the notion of cybersecurity just goes through the roof, where everyone's like, how do we lock this down? How do we make sure that all these new IoT devices are not easily exploited and hacked? And the answer is like, good luck, man. Those things, there's so much, it's so complicated as it is. There's got to be a million ways to get into our infrastructure and hack it. So ironically, all our technology, as powerful as it makes us, also makes us really vulnerable. So now we have to figure out how to lock all this stuff down and how to prevent it from being used against us. And that's probably the scarier part about IoT.
Give a little time for the child within you. Don't be afraid to be young and free. Undo the locks and throw away the keys, and take off your shoes and socks and run you. La, 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 la. Give a little time for the child within you. Don't be afraid to be young and free. Undo the locks and throw away the keys, and take off your shoes and socks and run through the meadow and scare up the milking cows. Run down the beach kicking clouds of sand. Walk a windy weather day, feel your face blow away. Stop and listen, love you.
Bicycles, tricycles, ice cream, candy, lollipops, popsicles, licorice sticks, Solomon, Grundy, Raggedy Andy, Tweedledum and Tweedledee, home free. Like your love.
It's not home, but with every well-considered detail, it becomes one step closer. No wonder more people choose Delta than any other airline.